Hey there, thanks for joining me for example 7.3.1. A grocery store is having a sale on peanut butter and jam. Customers are limited to buying 3 jars of jam, but only 1 jar of peanut butter per visit. Let's let X represent the number of jars of jam, and Y represent the number of jars of peanut butter that a randomly selected customer will buy. The joint probability mass function, or joint PMF, for X and Y is given here in the table below. So P of xy, these are probability values. Here are the values of little x, right, that x can take. X, where the number of jars of jam are limited to 3, so we can have 0, 1, 2, or 3 jars of jam bought by each customer. And y is the number of jars of peanut butter, which can be 0 or 1. So we're asked to find the value of k. And so we are going to use the property that the sum over all x and all y values of the probability, the total probability has to be 1, which means that the sum of all the values in this table must add up to 1. So 0.13 plus 0.17 plus all the way up to 0.05, including our k value, so plus k, must equal 1. So I've added up these values off screen, and that gave me 0.86 plus k has to be 1, and so k is 1 minus 0.86, which is 0.14. So we can put that into our table, 0.14 for k. Next question. What is the probability that a randomly selected customer buys 2 jars of jam and 1 jar of peanut butter? So using the notation of x and y, this is the probability that x is 2 and, with a comma, y is equal to 1, which using the PMF, the joint PMF, is P of 2, 1. Now, there is no formula to plug this in. We are literally looking in the table. The probability that x is 2 and y is 1 is right there. So the probability that we have 2 jars of jam bought and 1 jar of peanut butter is 0.10. Probability that we buy 3 jars of jam and no jars of peanut butter. Not we, but a randomly selected customer. So x is equal to 3 and y is equal to 0. Well, that's P of 3, 0, and we're finding that in exactly the same way. X is 3, y is 0. We're looking right here, and so that probability is 0.08. Now, the next two questions are a little bit more involved. Not much, but just a little bit. What's the probability that a randomly selected customer buys 3 items total? So how do we write this in terms of x and y? Well, that's the probability that x plus y, that's our total, is equal to 3. So in the last video, we saw an example of how sets A could be described in terms of equations of the random variables, and here's a perfect example, right? So our set A, which is not mentioned anywhere, right? You could think of this as a set A of all little x and y values such that x plus y is equal to 3. So that is more of a theoretical way of thinking about it. This is all that anybody would sort of ever write. The probability that x plus y is equal to 3, well, we have to think about that. What are those possibilities in the table? Well, clearly, we could buy 3 jars of jam and no peanut butter. We could also buy 2 jars of jam, so x is equal to 2, and 1 jar of peanut butter. Could we go down further? Could we buy 1 jar of jam? Well, to get to 3, we would have to buy 2 jars of peanut butter, and there is no column for 2. And so those are the only 2 possibilities in our support. And so this is P of 3, 0 plus P of 2, 1, which are conveniently the same values that are up in the previous 2 questions. So 0.08 plus 0.10 or 0.18. And lastly, what's the probability that a randomly selected customer buys fewer than 2 items? So in terms of x and y, I would write this as probability that x plus y, the total number of items, is less than 2. Not less than or equal to. It's not at most 2 items. It's fewer than 2 items. So that means that we have to find x and y values that can add up to values that are less than 2. Well, obviously a customer can come in and decide that, oops, no, they forgot their wallet at home, they're not buying anything, and so x is 0, y is 0. We could have the customer buy 1 jar of jam and no peanut butter, or the other way around, 1 jar of peanut butter but no jam. And so those are the only 3 possibilities. If we go up any further, right, then we have a value of 2, and that means the total will not be less than 2. So we're going to look at those 3 values in the table. We're looking right here. So 0, 0, 1, 0, and 0, 1. So we're going to add up those 3 values. Probability that x is 0, so if I'm being formal, I'll write this as p of 0, 0, plus p of 1, 0, plus p of 0, 1, and so p of 0, 0 is 0.13, p of 1, 0, 2, 1, and p of 0, 1, 0.17, and so what do I get? If I add these up, I get 17, 30, 51, 0.51. In the next video, we'll take a look at how we manage jointly distributed random variables when those variables are continuous.